Hello. If you are like me, you've made games on Unity, you've tested them out with server and clients, but when you went to go online and put them on a permanent server, like on your Amazon web server, you started running into problems, and that's what this video is about. I'm going to help walk you through some of those questions, especially because Unity 6 has made a lot of changes to the netcode system. And we're going to be going over some of the shortcomings that currently exist in 2025 with that. What I'm not going to be doing in this video is I'm not going to be showing you how to set up your Ubuntu server. I'm going to assume that you already know how to do that. You've set up your SSH access and you've had your website certified with SSL. For this, you are going to need Unity 6. Like I said, there has been a lot of changes in Unity 6, including adding support for WebSockets. WebSockets on WebGL is going to be necessary for you to host your online browser-based games that are multiplayer. So it has to be Unity 6 or above. You also need to access your Ubuntu server, and you're going to need to use NGINX or NGINX instead of Apache. And the reason for that, I'll show you later. It has to do with some of the shortcomings that currently exist. We'll go over in a moment. We are going to do this in a few different steps. The first step, to create the server and set it up with NGINX and then test it. And the last two steps is to create the client and test that. We're going to be doing this all from a very, very simple Unity script, and we're going to test the script independently of our game. I highly recommend doing this. Create a new scene in your game or create a new Unity project. And the reason why I say that is because WebGL introduces a lot of problems for your Unity game. So if you think that you're just going to be a click and your Unity game's working great on WebGL, you might be surprised at how many problems you'll have in WebGL. So we need to have a completely empty Unity project to be working with. And we don't want your whole game and all your canvas and all your objects to be getting in the way of us knowing whether or not your server's connectivity is working. Yeah, we're going to be working with the server connectivity. So when we're talking about what do you type in, what port do you use, what IP do you type in, which functions do you use, and you can tell maybe that this is generated from ChatGPT, but let me say you cannot trust LLMs right now, at least, to help guide you through this process, because Unity 6 has made so many changes. The LLMs, even if given documentation, they don't seem to know their way around this. This is definitely advanced enough that the LLMs are going to have a hard time helping you with it. Although they produce this nice little chart for us, I'm going to go through right now. So right now we're going to be talking about how you configure your server and your client. Your server, what ports are you going to use? What IP address are you going to use? Your client, same thing. What ports, what IP, what settings? Do we enable WebSockets? Do we enable secure connections? Do we enable remote connections? We're going to talk about that here. And these are the major points I'm going to be hitting home. You're going to have to use port 443. That's your SSL port. And you're going to have to be using your default domain. So you're not going to be able to use example.com/mygame or mygame.example.com, at least not right now. Hopefully in the future, there's better support for those locations and subdomains. But right now, they all seem to be broken, or there seems to be complications with them. What you really want to do first and foremost is just get a basic connection working. That means you're going to use your SSL port 443, and you're going to use your primary domain. While you're testing this, your website's going to go down because or at least the HTTPS version of your site's going to go down, because we're going to take over the site and we're going to forward everything to your server at first. Okay, so now if you wanted to, you can try to use some other options, trying to use subdomains, trying to use locations, trying to use different ports. However, these things don't work. You can kind of see there in the cons list. Subdomains don't work. Locations don't work. different ports are not going to work because of security boundaries and because of the limitations of the Unity transport system. As of right now in 2025, we're using Unity 6.1. If you're going in there and you try to connect directly to a port, it's just going to fail. You're going to get lots of these screens. We're looking at the Google Chrome DevTools screen right here, and you're going to go through a lot of these if you don't put everything in just right. You've probably already seen some of these if you're watching this video. I wouldn't be surprised. First, we're going to be talking about creating your scene, and like I said before, it's okay to use your existing game, but create a new scene. We're going to make it bare bones scene. All I've done is I create a game object, and I've added my network manager, which is always required for these NetCode with NGO projects, and I added my Unity transport. I believe that automatically gets added when you're filling out your network manager. And you might notice I erased the address and port because we're going to be setting those by hand, although in theory you could set them here. The reason why we would want to set them by hand is because we're going to use different address and ports for our server and for our client. So it's better just to leave that blank because we're going to be doing that in a script. I did select use WebSockets and use encryption, and we're kind of going to double down on that in a moment because we're going to open up our custom script, which will also set those variables. All right, well, let's take a look at our custom script now. This is where kind of all the magic happens. This is probably why you're here. We're going to be deciding exactly what to type where. The first thing is we always need to determine if we're working with the server versus the client. And to do that, we check if there's graphics, because if there's no graphics, that means it's the headless server. It's the server that's only there to connect the clients. It's not showing any, displaying any graphics. Then we're going to come down here. We're going to be using the transport. So if you're not familiar with networking, and I'm not even that much, the transport, you can see it as the details of how that data is going to be sent between the server and the client. So that's what we're going to be working with here, setting the settings for. We have to use WebSockets here. And that's because the TCP, the UDP, all of those other methods of communicating between a server and client, they don't work for browsers, because browsers only work with WebSockets, and it's one of the limiting things about browsers. But that's the great thing, is that Unity just recently made it possible to use WebSockets to do all this through WebGL, which is great, really, but there are limitations that we've already started covering and will continue to. So now we're checking if it's the server or the client. For the server, we're not going to set it to use encryption. Now, if you want to, you can, but you are going to get some error messages about certifications. So I left it off for now. I would just recommend leaving it off for now and then try and upgrade to it if after you've successfully had a connection. And we're going to set our IP to 0.0.0.0. All that means is that it will accept a connection from anywhere. It'll accept a connection from the same machine itself. It'll accept a connection from that LAN network, that's all connected, like the 192.168.1 thing. It'll accept a remote connection, like your static IP address we're going to talk about in a moment, but it'll accept a connection from anywhere in the world, basically. And then we're going to be using our custom port. So the default custom port 7777. I like to use the range of like 3000 to 3030. It doesn't matter too much as long as it's a unique port and it's something that's been opened on your firewall. Very important. We open that on our firewall. I will go through that and how to do that on Amazon Web Services, at least for Lightsail. It's very similar in other ones. Sometimes, and you have to be careful with this, sometimes you have multiple firewalls, like you have the built-in firewall with Amazon Web Services, and then you might have another firewall you've accidentally installed in Ubuntu or whatever it is, so just be careful with that. You got to make sure that port is open. That's your custom port. Now, you might be noticing already, hey, the port here that the server's listening to is not the same port that the client's listening to. This is the client down here. The reason why we're using 443 is that is our HTTPS. That's our SSL, our secure port. And there's limitations to browsers and WebGL that basically say we won't accept anything except this port. So it's really important we use that SSL, that secure port, for our client. That doesn't mean that we can't connect these two. We are going to. We're going to connect them through our routing service, our NGINX service. So I'll show you how to do that in a few minutes. But for now, our client, we're going to set to the secure SSL port. We have to set it to that port. You know, if you chat about this with ChatGPT or something, it's going to get it all wrong. It's one of the limitations I've noticed with LLMs. The Unity 6 is newer. It gets very confused with these advanced things. You have to have that secure port for your client. And I'm also going to be using a real IP address. This is the static IP address associated with my website. I can't use my web domain. And that's another limitation with the WebSockets and the security. You can really tell, you know, that WebGL and Unity, that they're taking their security very seriously. I used to work with multiplayer games in Adobe Flash, and we all kind of know what happened in Adobe Flash. It had security exploits, like a lot of them. So this is why everything's so stringent now these days with the WebGL, I assume. And then client secrets, that's also known as common name. That's where we're going to put our domain name. We do need to do that. I think it's something to do with authentication, but we need to put in our client secret, which is our common name or our domain name. All right, so it's really important we do all this in this order. Now, it might be tempting to try to connect to a subdomain or to try to connect to a location. Those don't work right now, at least. I think eventually Unity is going to get that working, but right now it doesn't. There's even a spot to put locations, which can be very confusing. You might want to type it in here. And that would work if we weren't doing socket connections. The problem is that none of this works with socket connections. So because we're on WebGL, because we're in browsers, we're limited to having to use the domain and to having to use SSL connection. Now, you might be thinking that this is going to be a big problem because that domain is your made website, and SSL, that's the main way regular clients connect to your website to view your website. We're going to have a fix for that in a moment. I'll go over with you. But first, let's go down here where we have to start our server or start our client. You got to choose one or the other. You got to start a server or a client. This is for testing locally. It's using the tag system that you're probably familiar with if you've been making a multiplayer game. It's here, the multiplayer mode system. You got a host tag, you got the client tag, and that's for testing it locally. Now, more importantly, though, is when you're in production, you got to be able to tell that it's a server. So we use that is headless again. And again, that's from this right here. You're going to need to type this in. You have the is headless, and then you have down here start client otherwise. And if you know, this is the only important part is right here, really. You could delete that if you wanted to. But I like to leave it because you never know when you're going to need to debug that server, and it'll help a lot to have all that. All right, and then you got your callbacks. This is really going to be how we know 100% certainly that we successfully connected, because it's going to show that we connected and disconnected. All right, so we have our custom script now, and we're going to go on to our next step. Our next step is going to be to upload that server. We'll open up Unity, and we're going to be creating two separate game files. We're going to create the server, and we're going to create the client. So we're going to go to Build Profiles, and I apologize for my error messages down here. I need to, I think, maybe reinstall Unity. They haven't really caused any problems, but there's always those 3 errors that just started a couple days ago. I will address it. I don't think it has anything to do with what we're working on today, though. So we have the Linux server. That's going to be our headless server. We're going to choose just our scene, our test scene that we're connecting with. And then we're going to click over here. You might have a button that says switch to this type of profile, that make it active. You're going to have to click on that. You push switch platform. So go ahead and push switch platform and then push build. This is going to be our file name. This is really important. This file name is the exact name that we're going to be using to run on our server. So we're going to have to use PM2 and say, hey, run this file. And push save. And give it a moment to run. Now, the purpose of this video is not to help you understand how to transfer files. So I hope you forgive me if I don't go into detail about how I'm going to do it. You can do it however you want. But the point is, that we have to move these files onto your web server. So for me, what I'll do is I'll use VS Code, and I'll just do a git push. And then I have a special command I call push all, and what it does is it pushes to my web server. And bam. So once you get on your web server, you should be able to find it. And you can see here, I was able to find it here. And then we're going to want to use PM2 to run the process on your web server. I already have mine running, but I'll show you right now how I got it running. I use this command here, PM2 start, and then your path. And again, we're looking for that Linux build, that headless build. If you haven't used PM2 before, you should get used to using it. It's a great program for managing your processes. We successfully created and uploaded our game server onto the web host. Next, we're going to be configuring NGINX for routing. I'm not going to go over in detail what NGINX is, but it's basically a web server and a reverse proxy. It can be used to host static files, but more importantly, it routes visitors and information traffic through your website to the destination it needs to go, similar to Apache, but it's kind of a newer one. It's faster and it's very common. It's almost always used for any major website. I'm going to show you the main script that we're going to be using. So when you go to modify your config file for your website, you're going to type in that command, that nano command, and we're going to go down to the 443 section of your site's config file. In that section, we're going to need to add this. You can see how it says location dash. That means that the location is the index location. It's the main home page. So we are going to be kind of hijacking your main domain page for our WebSocket. And we're going to say, hey, if someone goes to the main domain page, try to pass them onto our game server. So I'll use that same custom port that my game server is running on. I say, anyone coming to my website, go to this game server. But the trick is down here where we have a fallback for normal requests. So that's like someone visiting your website. So we have the fallback that sends you to your regular website. So you'll want to use your regular website's backend port here. Now that can be a problem if you're using Apache right now and maybe, I don't know, your website's like PHP or HTML files just being served statically. You're going to have to figure that one out. But this little trick here is really useful because it's going to allow us to serve our web game server on the main domain without using subdomains and without using locations. Which is what is required of us right now in the current state of WebGL and Unity 6. So let's actually go into mine and view it. I've already set it, of course, but you can see here how I have the very top here. It says listen 443. So this is where we're linking our two ports that we saw earlier. 443, that's the client's port. And then we go down here, the base location, the base route. We're going to send that to 3018. And we always use localhost there. And then we have our fallback to our regular website. Everything looks wonderful, so I'm going to Control X. And I'm going to refresh NGINX by first sending this command to make sure the file is okay and the syntax is good. And then sending this command to reload NGINX itself. And now it will take effect. All right, so the next step is going to be to test the server. So our server is up and it's working and we're ready to test it. So instead of testing the client and the server at the same time, we're going to install a package called WSCat. You can look this up. It's a really simple one to help test socket servers. So we're going to do WSCat and then your domain name, and we're going to push return and hope that it works. It did work. Now, if it doesn't work for you, there's a really good reason why it wouldn't work is probably your firewalls. So I do want to go over how to open up the firewalls next. So to get started, I open up and logged into AWS. And this works for EC2 more or less, but I'm going to be using Lightsail, so I open that up. And then I open up my instance. and I go down to networking. I think under EC2 it's something like security host something or other, and it's a little bit more complicated. But when I scroll down here, I have a couple things. I have my public IP address, which is very important. Earlier on, I showed you guys this here, how we have to use our static IP address. That's the address right there. You can see that's where I got it from. I got it from Light Sales public IP. That's going to stay like that for a very long time. I think mine's been like that for years. So it doesn't have to be updated often. Although if yours does seem to be changing a lot because your web host seems to change it a lot, it is possible to keep it updated. Other methods, if you look into it, you can set up this script to receive variables from JavaScript, so you can send variables into WebGL, and instead of doing it like this, you could be typing IP. That is a possibility if you need it. I'm not going to go over how to do that, but it's possible. Now, if I go down here to our firewall rules, I have a rule to open up all my ports, including 3018 is the one I'm using. You might be using 777 or whatever. You just want to get that set up for whatever port you're using, your custom port. That loud train is awful. Anyways, so we have our firewall opened, and now hopefully when you go to this and you connect, you will show that your server's working. So our next step is going to be to create and upload our client. And that's going to be pretty easy because we kind of already written most of our client's code. We're looking at the client code here. Basically, it's going to do this. It's going to set our connection data to an actual IP, not our domain, and then our SSL port, or 443, and we're also going to let it know what our common name is, and we're going to start the client. Those are the important steps. So next, to create that actual file for WebGL, we go down to here to web under our build profiles. So that's file, build profiles, web, and we switch to the platform. I notice this one tends to take even longer than the other, but we're gonna go ahead and build that. All right, well, I'm definitely gonna speed that up. This took a while, so feel free to pause while yours goes. We created this web build file here. All right, so for me, I like to upload my web builds using SCP. The reason why I don't use the method I uploaded my server in is because it's a very large file, so it doesn't work with Git correctly. So I'm just going to do that real quick here. Let's get this uploaded. And we can check this out too and make sure it got uploaded. And you can see there, web build. And we have all the files there in the web build. There's an index file that we can open. And that's going to be our very last step, is we're actually going to be able to test our client out. And let's go there right now. In order to know what's going on, we'll definitely have to go to the inspect screen on Chrome. Cross our fingers here, and yep, it worked. We didn't have any major errors here, and we got our client connected. So yeah, this next step would be to start bringing in game objects, having things sync, maybe connecting it to another scene of the game, whatever we need to do. Now, I do expect that you're having an error right now, if you're following along, related to BR or gzip and your compression. And that's because I kind of flew right over issue here that can be fixed by NGINX, and that has to do with compression. So let me show you how you fix your compression problems. We're going to open up our NGINX, and you can see some things at the top. I'm just going to go through them really quickly. This first one here, the Acme challenge, you might recognize. When you set up your SSL, which is important for this, if you haven't set up SSL or HTTPS yet, you're going to have to do this. You have to kind of prove that your website is owned by you or whatnot. So you have to get an authentication certificate, and to do that, you need to be able to pass like a challenge with Let's Encrypt or another service. So that's why I have that there, is for renewing my SSL certificates. You are going to have that or another method of getting your SSL certificate. And then the other big one is down here. There's our SSL certificates, by the way. Another big one is down here, because down here is where we're going to have mention of these compression systems. This BR compression, I think, is the default one in Unity, and it will keep your game from running. This is how I dealt with it from mine, and NGINX is great for dealing with this problem. What it does is it looks for all the BR files, and then it allows encoding, or it prevents them from being a problem in WebGL. Honestly, don't really understand how this works, but it's going to be an issue for you as well, your first time putting a WebGL file up. If you've ever done other non-multiplayer WebGL files, you probably don't have a problem with this, because this does happen regardless if it's multiplayer or single-player WebGL. But yeah, it's definitely an issue that you have to look at, and this is the main way to fix the problem, is by handling that compression in NGINX. All right, well, here we go. We were able to get our clients connected. If you have any questions, feel free to ask, and I hope you subscribe to my channel and check out my game I'm working on. So long.